recently we've been looking at Euler paths and Euler circuits the past couple days. Now, as a refresher, an Euler path is a path around a graph where we start at one vertex and we cross over every single edge exactly once without repeat. An Euler circuit is a circuit, meaning that we start at a vertex. Now, being Euler, an Euler circuit is we start at some vertex, we cross over every single edge of the graph, and we return to the starting vertex. So a circuit is different in that it has to begin and end at the same vertex. Now, how we can tell that a graph has an Euler path, has an Euler circuit. So a path, if there are 2 or 0 odd vertices, we're going to have a path. If there are 0 odd vertices, then we also have a circuit. Now, a circuit is a special kind of path. So in order to tell, what we need to do is first look at the vertices that we have. The vertices are the different corner points on a graph. The edges are all of those segments that connect one or more vertices. So this first graph here on the left, look, this vertex, there's one edge coming out of it, so that is an odd vertex. This vertex, we've got 1, 2 edges coming out, it's an even vertex. This 1, 2, 3 edges, that is an odd vertex. 1, 2, 1, 2, both of those are even vertices. So we're going to have an Euler path because we have 2 odd vertices here. Now, the way it works out is we must begin and end at those odd vertices. It can be either one as long as we begin and end at the other. So this, we can start at this point, come across, down, over, up, or we can go backwards. Same thing, we have an Euler path. We can cover every single edge exactly once without repeat. Now, some graphs don't have that. So 1, 2, 3, that one's odd. 1, 2, 3, that one's odd. 1, 2, 1, 2, 3, we've got odd. 1, 2, 3, odd, odd, odd. We've got 6 total odd vertices. So this has nothing. No Euler path, no Euler circuit. Now, sometimes we want to have a circuit. We want to have a path. Say we have a postal route in here. I know it's kind of hard to see. I'll enlarge just a little bit. If we have a postal route, the postal worker needs to leave the post office, deliver mail all over the place. They still need to return back to the beginning. So in this case, this graph represents something that is not a circuit, is not a path. If we count up our odd vertices, we have 1 odd vertex, 2, 3, 4 odd vertices. So sometimes we need to make a circuit. Well, the post office, the postal workers need to get back to get tomorrow's mail. The garbage truck can't just end at somebody's street and dump all the garbage right there. It's got to get back to the refuse facility. So we have this process called Eulerization. When we have a graph that does not make a circuit, and we need a circuit, we're going to do something called Eulerization. And this is the process of converting a graph to a circuit. Euler is, I can't spell anything. Eulerization, that's an A. Now here, odd, 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 odd. We have 1, 2, 3, 4, 5, 6, 7. That can't be right. We need to have an even number of odd vertices. Uh-oh. What am I missing? That's odd. That's odd. That's odd. 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 1, 2, 3. Even, 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 even. There it is. Missed it right in front of me. So we need to turn this into a circuit. So this process of Eulerizing a graph, we begin identifying all of our odd vertices. And then we're going to add segments. We're going to add segments that represent a repetition of a segment. Like this is indicatory of like a garbage truck going forwards and then backwards down a street, because sometimes you have to repeat a street. And we cannot create any new segments. We're just going to repeat segments. Now we pair up those vertices that are closest to each other, and we want to do this with the fewest number of repeats as possible. Now I look, bottom right, these two are pretty close to each other. So in order to connect these 2 vertices, create a circuit, I'm going to repeat paths until I make the connection. So if I repeat this edge, I have now turned this into an even vertex, now turned this into an even vertex. The nearest vertex to this looks like it's going to be this one up here. So we're going to repeat segments. Now, when I repeat one, this now becomes an even vertex, but this becomes an odd vertex. I've got to make the connection. Now they are both even vertices. These two are close together. Repeat that segment. That is now an even vertex. And then repeat the segments to close off everything by adding in those extra segments. Now, it's not a new segment. This is just indicating that we have a repeat segment. That's called Eulerization, how we turn a graph into a circuit. That's what we're going to be doing today. Good luck.